morning, children. Today's class we are going to learn about absolute value. What do you mean by this word absolute value? We call mod x. See, in lower classes when we did problems under area, volume, suppose my answer is negative. We say take modulus so that I treat only positive number. So this modulus is a magical box. Even if you put negative number inside, it comes out as positive. So modulus, you mustn't forget something that changes your negative into positive. So mod x, my answer, if it is 7, it is 7 only. So whenever it is positive, I keep it as it is. Whenever it is negative, I change the symbol. So I write minus x. So inside modulus, positive means my answer is as it is. Inside the modulus, if it is negative, you change the symbol. So mod x is x when x is greater than 0 and it is minus x when x is less than 0. This we call the absolute value of x. Suppose equal to 0 comes also, I treat x as it is. Now you are given a problem like this. How to write it? Mod x less than 7 implies minus 7 less than x less than 7. So it's a formula like I can treat mod x less than r, let me say. I write minus r less than x less than r. If it is equal to, here also I use equal symbol. And if mod x is greater than r, how will I write it? Minus r greater than x greater than r. And here equal symbol comes, use equal like this. R should be positive. Then only I can apply this format. Now, mod x greater than or equal to minus 2. Is it true? Modulus is always positive. Therefore, it is always greater than minus 2. This implies this particular inequality true for all x belonging to R. Suppose I say mod x less than minus 2. Is it true? No solution. Why? Modulus is always positive. I cannot have modulus to be less than a negative number. So while doing modulus problems, look at the right hand side value. If it is positive, I write like this. If it is negative, greater than negative number means it is always true. So put x is a real number. Any real number, it's correct only. But less than minus 2 means this is not at all possible because modulus is always a positive quantity. It cannot be below a negative number. So my answer is no solution. Having all this in mind, let us proceed on to exercise 2.2. Now suppose you have mod xy. I can write it as mod x into mod y. It is not wrong. Suppose I have mod x by y. I can write mod x by mod y. But whenever I write something in the denominator, ensure it is not equal to 0. In all the mathematics problems, do not keep denominator to be 0. Anything that comes in denominator, immediately ensure that it is not equal to 0. Mod x plus y. Can I write it as mod x plus mod y? No. Now my answer is less than or equal to. So into or division, I can split modulus. But in plus symbol, I write less than or equal to mod x plus mod y. But these are the basic things that we often use in the exercise problems. Mod x less than or equal to r implies minus r less than or equal to x less than or equal to r. Mod x greater than or equal to r implies minus r greater than or equal to x greater than or equal to r. So let us proceed with the exercise now. First question, solve for x mod 3 minus x less than or equal to 7. What is the formula? Mod x less than or equal to r minus r less than or equal to x less than or equal to r. So use the formula in the question. Here 7 is coming. So write minus 7 less than 3 minus x less than 7. Equal symbol means put equal. The next step. 3 I can bring it to the other side. So how does it come? Minus 7 minus 3 less than or equal to minus x less than or equal to 7 plus 3 will come to the other side as minus 3. This side or this side it comes as minus 3. So I get minus 10 less than or equal to minus x less than or equal to 4. Negative symbol comes. Throughout change it. See, 8 is greater than 6. But what about minus 8? I will have less than symbol. So whenever we multiply by minus sign, inequality reverses. The same idea, 4 greater than 2. But what about 1 by 4 and 1 by 2? This is bigger. So when I multiply by minus sign, inequality changes. When I take reciprocal, inequality changes. 2 times we change the inequality. Plus symbol when I multiply by minus. The numbers given when I take reciprocal. Whenever I put upside down, greater becomes less. So have that idea here. There is minus x. I am multiplying by minus 1. So whenever we multiply by minus 1, inequality reverses. So I get minus 10 will become plus 10 greater than or equal to x greater than or equal to minus 4. So this is my answer. But we never put negative here and positive here. Reverse and write it. So this I will write minus 4 less than or equal to x less than or equal to 10. Now this is the answer. Minus 4 less than or equal to x and less than or equal to 10. Question number 3. Same pattern. Again we have less than or equal to. Mod 3 minus 3 by 4x less than or equal to 1 by 4. So using this formula, minus 1 by 4 less than or equal to 3 minus 3 by 4x less than or equal to 1 by 4. Bring plus 3 to the other side. Minus 1 by 4 minus 3 less than or equal to minus 3 by 4x less than or equal to 1 by 4 minus 3. Taking LCM, minus 1 minus 12 by 4 less than or equal to minus 3 by 4x less than or equal to 1 minus 12 by 4. All by 4 I can cancel. Provided it is a positive number. Positive numbers I can cancel in the numerator or denominator. It will not alter the inequality. The very next step, simplify the answer. Minus 1 minus 12 will be minus 13 less than or equal to minus 3x less than or equal to minus 11. Change the symbol throughout implies reverse the inequality. So what I get? 13 greater than or equal to 3x greater than or equal to 11. 3 I don't need. Divide by 3. Positive number, don't change the inequality. 13 by 3 greater than or equal to x greater than or equal to 11 by 3. Reverse and write it. 11 by 3 less than or equal to x less than or equal to 13 by 3, and that is the answer. Fourth question. Mod x minus 10 less than minus 3. Mod x less than minus 3 plus 10. Or I will say mod x less than 10 minus 3 is 7. Same formula we will write because it is 7. Minus 7 less than x less than 7. No equal symbol, so only less than. So minus 7 less than x less than 7, and that is the answer. We'll proceed on with the second problem. Mod 4x minus 5 greater than or equal to minus 2. What is the formula? Mod x greater than or equal to r. But before even doing, modulus is always a positive quantity. So greater than or equal to minus 2 is always true, isn't it? Because modulus is always a positive quantity. So this is always true for all x in the real numbers. Any x I put, modulus is positive. So definitely greater than or equal to minus 2. Before going into the second problem, let us see the inequality regarding modulus. Mod x less than r. When I say, I can represent it as an inequality like this. Minus r less than x less than r. First type. I can write it as an interval. X belongs to minus r to r. I can write it in number line. Left end minus infinity, right end plus infinity. Minus r a number over here, plus r a number over here. Whenever I say in between, I say like this. So less than represents x is inside minus r and r. Or I can say x lies between minus r and plus r. So these are the implications I understand when I say mod x less than r. First thing, minus r less than x less than r. Second thing, I can write it as an interval. X belongs to open interval minus r to r. Third, I can draw it in the number line. Whenever I say number line, the right end is plus infinity, very big number. The left end is minus infinity, very small number. Minus r to plus r, I have x inside. Either I say x is inside or x lies between minus r and plus r. The same idea will follow for less than or equal to. The only extension is less than or equal to I put. And x belongs to closed interval. So when it is less, it is only open interval. When it is less than or equal to, I put closed interval. The number line is same. How to distinguish? Here it is minus infinity to plus infinity, minus r to plus r. Here I keep bold point and it is inside. Whereas here I keep a open circle. Open circle says n values are not included, but a bold point says n values are included. And the same thing only I write here also. Either inside minus r and r, or I can say x lies between minus r and r. It is one and the same for both. Suppose I have mod x greater than r. Now how should I do it? My question is mod x greater than r. How will I write it? Minus r greater than x greater than r. In other words, x is in minus infinity to minus r or r to infinity. The number line we draw like this. Left end minus infinity, here plus infinity, minus r plus r. We put open circle because it is only greater than symbol. X greater than minus r. X greater than r means here. Minus r greater than x means here. So where is the shading coming? It is beyond minus r and plus r. So how will I write it? X belongs to minus infinity to minus R and R to infinity. This 2 I write, so I put the union symbol. This or this, it is correct. And how do I write the words? X lies beyond, I can say, or outside. X lies outside minus R and plus R. So the same idea I can use for equal to symbol. Mod X greater than or equal to R. How will I write it? Minus R greater than or equal to X greater than or equal to R. How do I write this? X belongs to minus infinity minus R. What bracket? Square bracket. Whenever equal symbol comes, square bracket. Whenever just inequality comes, open bracket. Same idea, union, I write R to infinity. Now the number line, same idea, this side minus infinity and in the right plus infinity, minus R plus R. It is open circle for greater than, it is a bold point for closed interval. Now also it is outside only. So X lies beyond minus R and plus R. That is the solution. Look at the exercise problems. However they ask you, you must be able to write it. Inequality model, modulus model, interval model, number line model. Same idea. However it is asked in the next exercises. Try to answer. Simply to remember, less means inside, greater means outside. So let us have this in mind and proceed with the exercise problems. Question number 2. Solve and give the solution in interval form. 1 by mod 2x minus 1 less than 6. Whenever I write reciprocal, I put inequality reversed. So this is reciprocal, this is also reciprocated, less becomes greater. So which formula should I use? The very first one. How will I write it? Minus 1 by 6 greater than 2x minus 1 greater than 1 by 6. The very next step, bring minus 1 to the other side. Minus 1 will go as plus 1 greater than 2x greater than 1 plus 1 by 6. Taking LCM, 6 minus 1, 2x greater than 6 plus 1 by 6. Or it is 5 by 6 greater than 2x greater than 7 by 6. Bring 2 down, that is divide by 2. This will become 5 by 12 greater than x greater than 7 by 12. How will I mark it in the interval? So I have greater symbol. How should I write it? X belongs to minus infinity to the first number 5 by 12. It is round bracket because only greater. Union, the other number is 7 by 12 to infinity. So we write the answer. X belongs to minus infinity to 5 by 12 interval, union 7 by 12 to infinity, and that is the answer. Question number 3. Solve and represent in number line. The given question, minus 3 mod x less than or equal to 5 to the other side minus 5. Minus 3 mod x less than or equal to minus 2 minus 5 is minus 7. Bring minus 3 down. When I change the minus symbol, 3 mod x inequality reverses, greater than or equal to 7, or mod x greater than or equal to 7 by 3. So what formula is this? Mod x greater than r. Mod x greater than r means I write x belongs to minus infinity to minus r, union r to infinity. So we write this minus 7 by 3 minus 7 by 3 greater than x greater than 7 by 3. Or in the next line, I can write x belongs to minus infinity to minus 7 by 3 union 7 by 3 to infinity. The next step, we draw in the number line. Minus infinity to infinity, minus 7 by 3, 7 by 3. So we have greater than or equal to means closed interval. The next step, I want to shade. Minus infinity to minus 7 by 3, 7 by 3 to infinity. So we have represented in the number line. Question number 4. 2 mod x plus 1 minus 6 I take to the right side. It is 7 plus 6. 2 mod x plus 1 less than or equal to 13. Mod x plus 1 less than or equal to 13 by 2. So long it was only positive. So how will you write the formula? Mod x less than or equal to r means minus r less than x less than r. Using that here, minus 13 by 2 less than or equal to x plus 1 less than or equal to 13 by 2. Take the 1 to the other side. Plus 1 will go as minus 1. Minus 13 by 2 minus 1 less than or equal to x less than or equal to 13 by 2 minus 1. Taking LCM, minus 13 minus 2. Here again LCM, 13 minus 2. Simplifying the answer, minus 15 by 2 less than or equal to x less than or equal to 11 by 2. This is less than. So my answer will be inside the interval. Minus 15 by 2 comma 11 by 2. Mark it in the number line. Minus infinity plus infinity. Minus 15 by 2. 11 by 2. And I want inside. So it is between. That is the graph. Question number 5. Solve. My first step. Mod 10x minus 2 cross multiplying positive number I can just multiply. And what is the formula? Mod x less than r minus r less than x less than r. Here it is 5. Minus 5 less than 10x minus 2 less than 5. Take minus 2 to the other side, plus 2. 5 plus 2. Minus 3 less than 10x less than 7. Dividing by 10. Minus 3 by 10 less than x less than 7 by 10. So positive number I multiply, positive number I divide, inequality is the same. So the solution is minus 3 by 10 to 7 by 10. Another way I can write like this as interval. So either inequality or as an interval. Question number 6. Mod 5x minus 12 less than minus 2. Can this be true? Modulus is always positive. Modulus is always positive. Let us not forget. So, mod 5x minus 12 less than minus 2 is not possible. A positive number cannot be below minus 2. Therefore, I will declare there is no solution, and that is the answer. So, exercise 2.2 is over with this. Practice the problems with mod x less than r and mod x greater than r, marking as inequality, as an interval, and also in the graph. Thank you.